Categorical variables are tutorial. Today, Jeff introduced a new type of variable, a categorical, or otherwise known as a qualitative variable. We saw variables of this type appear in the life expectancy dataset as well as in the skeletal remains dataset, and you were able to have a better understanding of these types of variables through the use of bar charts, relative frequency bar charts, as well as pie charts. Let's take a closer look at these new graphical measures. First, we will work with the life expectancy dataset, focusing on the new categorical variable region. We can obtain the table of counts by region with the table command. This tells us, for example, that 39 of the countries are in the Americas. For future use, we will store this table under a new variable called counts. We can also obtain the relative frequencies with a simple calculation. We will store these under a variable called relative frequency, and we know that to calculate it, we can divide counts by their total. Finally, to ensure that our new variable region is properly labeled in each graph, we will store the names of the regions in the new variable region names in the order that they appear in the table of counts. We are now ready to start plotting. We'll start with a bar chart, which can be created with the bar plot command. We want the bar heights, which is the first argument, to be the counts for each region. We will choose the colors of the bars using a rainbow command, specifying that we need 6 different colors for our 6 different countries. And we will set the names for each category with the names.arg argument, specifying that the names to use are stored under region names. You'll notice right away that not all of the region names have made it on the graph. This is simply a sizing issue with R. We can try to stretch the graph to be able to fit all of the region names. Similarly, with the bar plot command, we can graph the relative frequencies we created. Notice that the graph seems to look the same, but in fact the y-axis changes to reflect not the counts, but the relative frequencies. A pie chart can be created with the pie command, specifying the counts, the colors, and the labels. For Jeff's next example, the skeletal remains, after reading in the data, recall that the command attach allows us to use the variable names that are part of the dataset. Our first categorical variable of interest is the gender of the skeletons. So, similar to above, we will generate the counts or frequencies for each sex, the relative frequencies, and create the name variable. For the names, it's useful to know that males are indicated by a 1 and females by a 0. Now we can produce the bar chart, the relative frequency bar chart, and the pie chart. Do note that the color argument requires only 2 colors in this case, since we have only 2 categories, male or female. The second categorical variable of interest for the skeletal remains dataset is the mass category, or BMI category. This variable is stored in the dataset under the variable name BMI. Try to apply the techniques learned in this tutorial to the BMI categorical variable and see if you can recreate the bar chart, relative frequency bar chart, and pie chart that Jeff displayed in the categorical variables lecture.